Welcome back, everybody. Once again, here's the Fearless Teacher, and today we're going to talk about the domain and range of trigonometric functions. Alright, so now we're going to have a little definition. The value of a trigonometric function at the real number t, and that's your angle, is its value at an angle of t radians. Let's take a look at a graph once again. And with our graph, we're going to plot the point 1/2 square root of 3 over 2 because that coordinate lies on the unit circle. So let's see what kind of an angle we can get from this. I'm going to draw my line for my terminal side, and this point where it meets a circle is 1/2 square root of 3 over 2. That's our angle T. So what I'm going to do, just to demonstrate, is I'm going to drop my perpendicular to the x-axis, and that is the y length. And then I'm going to also draw out my x length to get my reference angle, or my 90-degree angle. The radius is 1, the short side is 1/2, and the large side is the square root of 3 over 2. And you should kind of recognize that as a triangle with where theta is going to be 60 degrees. You have the short side is whatever that is. The hypotenuse will be twice that. Twice 1/2 is 1. And the long side is going to be the square root of 3 times the short side, so there is a square root of 3 over 2. So we know that t is pi over 3, or 60 degrees, because that is I guess you would call it a 60, 30, 90 triangle. The sine of 60 is square root of 3 over 2, which we already know from our special angles. And the cosine of 60 degrees is 1/2. So let's look to see how these pair up and what kind of a pattern we have here. If you have the sine of 60 degrees is square root of 3 over 2, well, that's your y value here. And if you have the cosine, that's a sine of t. And if you have the cosine of 60 degrees is 1/2, that gives us our x coordinate, which is 1/2. So now, instead of having the coordinates of xy, for x is the x coordinate and y is the y coordinate, you can change that and call that the x coordinate coordinates with the cosine of t, and the y coordinate is the sine of t. So this makes it, and this is only in a unit circle for right now. So that gives you an idea of where we're going with this. So now we're going to talk about what specifically is the domain and the range of the sine and the cosine function. Let's start with cosine, and then we'll add sine. T is the domain. T is the number that you plug in for the radian or degree measure. And y is what you get for a result. So if you plug in 30 degrees for cosine, you will have cosine of 30 degrees is square root of 3 over 2. So that's how we get your x and your y. And y is the range. T can be any real number. So we say that t lies between negative infinity and positive infinity. And notice that my less than sign does not include equal, because we can't include negative or positive infinity because we can never reach it. So let's start with a diagram once again. And now we want to look at the range. And the range is how big the y can get and how small the y can get. Well, you can see that our circle only goes up so far and down so far. So we know that our range is going to be restricted. It's not going to be like the domain, which has all real numbers. So let's put our little, in our unit circle, let's put our degrees, or not degrees, our coordinates for 0, 90, 270, 360, or 0, pi over 2, pi, 3 pi over 2. And you can see that once again it's 1, 0, 0, 1, negative 1, 0, 0, negative 1. So I know that my coordinate is going to be cosine t is the x and sine t is the y. So let's start with our first coordinate. So at 0 degrees, cosine is 1. At 90 degrees, or pi over 2, cosine is 0. At 180 degrees, or pi, cosine is negative 1. At 270 degrees, cosine is 0. And once again, moving back to 0 or 360 or 2 pi, all the same thing, our degrees are 1. Now let's take a look. Let's fill in some things here for what t is. T went from 0 to pi over 2 to pi to 3 pi over 2 and back to 2 pi. So what was happening here? Our range of cosine cycles between negative 1 and positive 1. The smallest value is negative 1 and the biggest value is positive 1. So our range, which is the cosine of t, is going to go from negative 1 to 1 inclusive. All right, let's take a look at what the sine is. Sine is going to be basically the same thing, actually exactly the same thing. The value of t can be any real number, which can be written in interval notation as, in notation as negative infinity is less than t is less than infinity. And I will draw our picture again, and we'll label our main points on our quadrantal angles. And we notice once again we need to see how big sine of t gets and how small sine of t gets. Once again, let's put down that our coordinates are cosine of t, sine of t, or x, y. And now we're looking for sine of t. So on the first one, at 0 degrees, it's 0. At 90 degrees, it's 1. At 180 degrees, it's back to 0. At 270 degrees, it's negative 1. And at 360, it's 0. So once again, t has gone from 0 to pi over 2, or 90 degrees, to pi, or 180 degrees, to 270, or 3 pi over 2, and then back to 2 pi. So when t goes from 0 to pi over 2 to pi, 3 pi over 2 to 2 pi, what is happening to the sine of t? Well, it goes from a minimum of negative 1 to a maximum of 1. So the range, once again, is negative 1 is less than or equal to sine of t is less than or equal to 1. Let's recap. The domain and the range of the sine and the cosine function, they are the same. We have the sine function y equals sine of t and the cosine function y equals cosine of t. The t's are both all real numbers, and that's the domain. The value of y, when we plug in the real numbers, is the range. The domain of each one of them is all real numbers, which goes from negative infinity to infinity, and we can also write that in interval notation, which is negative infinity, comma infinity with parentheses, and once again the parentheses mean that it doesn't ever reach that. And the range is from negative 1 to 1 included, and we can write that with brackets, negative 1 to 1. So that's it for this one, folks. Go forth and do math.